Alright, hi, this is the second part of my video. Chosen to do my second project on the curve of pursuit. We're going to be seeing if vessel A ever reaches vessel B. Now vessel A is going to technically be like our predator or like our good guy. It could be either way. Then vessel B is going to be the prey, or it's going to be the bad boat. We're trying to get the boat with the good guys. Okay, so we know that A is traveling at a speed of alpha, and at time, or at t equals 0, it's going to be starting at the origin. And then B is going to be starting at 1, 0, and it's going to be traveling along the x equals 1 line. And after t hours, A is going to be at the point p equals xy, and B is going to be at the point q, which is going to be 1 beta t. So in order to first start solving this problem, we need to, and the problem is we have to make y a function of x. So we need to first prove that dy dx equals y minus beta t all over x minus 1. So we know that slope is equal to m. And we know that m is, slope is just another way of saying a tangent, tangent theta. And we know that tangent theta is going to be equal to dy dx. All right, so we have the left side figured out. Okay, so for the right-hand side, where we know where A and B ends up is going to be 2 points. And those 2 points look a lot like our slope equation. I'm going to write the slope equation here. It's going to be m. All right, so here I've already labeled x1, y1, and x2, y2. So we simply just have to write that in. So sub it in. So y2 is going to be y. And then we're going to have y1 is equal to beta t. And that's going to be all over x2, which is going to be x, minus x1, which is just 1. All right, and right hand side. And then all together, that's going to make dy dx equal to y minus beta t all over x minus 1. So we know the speed at which A is traveling, and that's going to be alpha. So now we need to know the distance it travels in that time at alpha t. So this distance is also going to be the length of the pursuit curve from 0, 0, 0, 0 to xy, which is where these are going to eventually meet. So we're going to use the arc length formula to show that alpha t is equal to the integral from 0 to x of the square root of 1 plus the quantity of y prime of u squared with respect to u. To do this, we need to figure out the length of y. So we need to divide the interval into lots of tiny parts and eventually use the mean value theorem. So first we're going to set up L, which is going to be our length. We're going to do L equals, so going to be P I minus 1, and that's going to be subtracting Pi. And that's just essentially our length there. And that's just us subtracting all of our little bits from the curve to figure out the length of this line. So now we're going to take the limit as n approaches infinity. So L is going to be equal to the limit as n approaches infinity of, and then we're going to do I equals 1, n equals infinity, wow, okay, infinity, and that's going to be the absolute value of Pi minus 1 minus Pi. Okay, we're going to let delta yi equal yi minus y minus 1, which is also going to be equal to f of x sub I minus f of x sub I minus 1. So we're going to rewrite this part here as, we're going to do P I minus 1 minus pi, and that's going to equal the square root of x sub I minus x sub I minus 1 squared plus y sub I minus y sub I minus 1 squared. And that's going to equal the change in x sub I squared plus the change in yi squared. Okay, and from here, I do need to erase the board, so just give me a second. Okay, I'll just rewrite that last part really quick. Delta x I. Okay, and then by the mean value theorem on this interval from x sub I to x sub I, there's going to exist some point of x sub I at some power. So we can rewrite f of x I, which is going to be this one over here, f of x sub I minus f of x I minus 1. That's going to be equal to f prime of x sub I to some power times x sub I minus x sub I minus 1. So that's going to make this one equal to the change of y, I'll just rewrite that there, it's going to be equal to also the change in x here. So we're going to have f prime xi at some power times the change in x sub I. All right. And then from this we can see that originally what we had written down of p of I minus 1 minus p sub I is going to equal the square root of delta x squared plus this here, f prime of x some power I squared times delta x squared. Okay, perfect. And now we can substitute in. So let me just erase really quick. Okay, so now we can substitute in from our part A equation, which is going to be rewrite part A equation. Match what I need here, which is I need alpha on the right hand side, or excuse me, the left hand side. So I'm just gonna rewrite this to be equal to t. Yes. Yeah. Okay. So this is gonna be t equals y minus x minus 1 times dy dx all over beta. All right. And we're going to set that equal to this equation that we got here, which is going to be 1 over alpha times 0 to x times 1 plus, it's going to be equal to 1, 1 plus y prime of u squared times du. Awesome. Okay. So we just simply divided by alpha on both sides and from here, and then we solve for t on the right hand side, which is what we did here from part A. for part C, we need to differentiate both sides of this equation to get x minus 1 times dw dx equal to negative beta over alpha times the square root of 1 plus w squared with respect to u, where w is equal to dy dx. So anywhere in this problem, we're going to replace it with w. Anywhere in this problem where we see y, or dy dx, excuse me. All right, so first we're going to multiply both sides by beta. So you got y minus x minus 1 dy dx, and then we're going to have beta for alpha. Okay, and then we're going to, let's see here. We're going to switch dy dx. Okay, so this is going to turn into dy dx. We're going to have dy dx minus x minus 1. And this is going to be dy, this is going to be squared. And this is going to equal to beta over alpha. Okay. All right, I'm going to erase a little bit. Okay. Actually, first, let's see here. We're going to get, we're going to switch this to, we're going to switch this to x, and then this du dx. This is going to be with respect to dy dx down here. We're just going to get rid of that integral. So then we're going to switch over to dy dx minus x minus 1 times dy squared dx plus dy dx equal to beta over alpha times the square root of 1 plus y prime of x squared dy dx. Okay. Right there, so we're going to have x minus 1 times dy dx. That's going to be equal to negative beta for alpha times, all right, so that's going to cancel out one of those. So we're going, oh, excuse me, that's not right. Sorry, we're going to, and then that's going to get switched over there and get rid of this squared. And then we're going to switch this y prime to a w. So negative ba, and then that's going to get rid of that one. And then going to switch, okay, and then we're going to have negative beta alpha, okay, cool. And then times 1 plus w squared with respect to u, because there's still a du here. Okay, perfect. And then we're going to switch this last w to, or slash y to a w, which is going to equal to negative beta over alpha times the square root of 1 plus w squared. Awesome, and that matches what we've been given. Okay, for part D, we're asked to use separation of variables to solve the last equation that we had. And we've been given a couple initial conditions. We've been given that x equals 0, that w equals dy dx, which also equals 0, and that is when t equals 0. So from the last equation, we had x minus 1 dw dx, and that's going to be equal to negative beta over alpha times the square root of 1 plus w squared with respect to u. Awesome. So now we're going to use our separation of variables technique. And that's going to essentially put this on this side, and then we're going to multiply, switch this into w, we're going to move, so we're on part E now, just wanted to save a little room here, so I'll just read the problem out loud. For alpha greater than beta, that is the pursuing vessel A travels faster than the pursued vessel B, use equation use equation 8 to, and the initial conditions x equals 0 and y equals 0 when t equals 0 to derive the curve of pursuit. This is going to be the curve of pursuit. It's going to be y equals 1/2 times the quantity 1 minus x to the 1 plus ba all over 1 plus beta over alpha minus the quantity 1 minus x to the power of 1 minus beta over alpha all over 1 minus beta over alpha plus alpha times beta all over alpha squared minus beta squared. So we're going to take our last problem and we're going to first integrate. So we're going to integrate, let's see, I'm going to do dy, and that's going to be equal to, we're going to move dx over because w equals dy dx. So I'm just going to multiply dx to the other side. 1/2, all right, 1/2 x dx. Okay, so this is just going to simply be y on this side, and we're going to have to use u substitution on this other side. We're going to set u equal to 1 minus x, and that's going to make negative dx equal to dy, or excuse me, du. Get rid of its tail. And so that's going to leave us with y equals negative 1/2 times the integral of u to the negative beta over alpha minus u to the beta over alpha du equal to negative beta over alpha. So we're gonna do equals integral from u to the n du, and then we're gonna set that equal to we're going to have that equal u to the n plus 1 all over n plus 1. And then, like I said, n is going to equal to beta over alpha. So we're going to sub everything back in that we've just done here from our u and our n, and we're going to have y equals 1/2 times 1 minus x to the 1 plus, negative 1 plus beta over alpha all over 1 plus beta over alpha, and that's going to be subtracting our u, 1 minus x, and then so that's a positive beta over alpha. Oh, no, this is supposed to be negative. This is negative, that's why it does that. Okay, so one of the x is going to be 1 minus beta over alpha, and all over 1 minus beta over alpha, but we do have a constant c, so we are going to need to solve for that. So I will quickly erase a couple things here. So, going back, we do know from the initial conditions given that y is going to be equal to 0. So we're going to set y equal to 0, and we're going to solve for c. 1/2 x, oh man. Okay. So we're going to move this c over to one side, and since that's going to be negative, we're going to multiply this side by negative. So we're going to get c equals negative 1/2. And then we're also going to, set 0, x equals 0, because that was another initial condition. I'll just write that over here. Y equals 0 and x equals 0, so I don't forget. So negative 1/2 times the quantity 1 to the 1 plus beta over alpha times 1 plus beta over alpha minus 1 times 1 minus beta over alpha. Okay, and from here, I'm going to multiply this by alpha and this by alpha to get rid of this double fraction. So we're going to have c equals negative 1/2 times alpha to the 1. Yeah, just kidding. Alpha, and then all over alpha, and then over beta plus alpha minus alpha times, or excuse me, all over alpha minus beta. Perfect. All right, and then that's going to be, we're going to get a couple loosey-goosey things in here, and this 2 is going to eventually cross out, and we're going to be left with c equals alpha times beta all over alpha squared minus beta squared. That's our c value. So we're going to plug that in to our y equation. So we're going to get this plus c. So y equals 1/2 already 1 minus x minus 1 minus x to the beta over alpha and 1 minus beta over alpha plus c, which is going to be alpha times beta over alpha squared minus beta squared. For part E, or excuse me, part F, we're asked to find where vessel A is going to intercept vessel B if alpha is greater than beta. To redraw our graph, we know that vessel B is traveling on the x equals 1 line, and we know that vessel A is traveling along, it starts at the origin and it uses this curve to track its prey. So we essentially, to figure out where vessel A will intercept vessel B, we're going to plug in x equals 1 because we know that that's where B is, that's where we know vessel B is, and and then y is what we will be solving for. So we're going to have y equals this problem here. We're going to plug in 1 for all of the x's we see. So we have 1/2, and this is going to be pretty easy. This is going to be 1 minus 1, so it's going to be 0, and this is going to be the same thing, minus 0 plus alpha beta over alpha squared minus beta squared. This 1/2 is also going to cancel out, so we know that y is going to be equal to alpha beta over alpha squared minus beta squared. So the point of interception is going to be at the point 1, because that's what we use for x, and then at the y value, alpha beta over alpha squared minus beta squared. Problem for this last part G, we're asked to show what happens when alpha equals beta and if A is ever going to reach B. So we're going to take it back. We're going to go back to our original equation before we integrated. So we're going to have the integration of dy equal to 1/2 the integration of 1 minus x squared minus the natural log of 1 minus x, and that is going to be with respect to dx. Awesome. We switch pens. All right, we're going to use u substitution again, just like we did last time. So u is going to be equal to 1 minus x, and dx is going to be equal to negative du. So we're going to have y equals negative 1/2 to be u. Oh, and then x is going to be, whatever, negative 1/2 u to negative 1 minus u. It's going to be du plus c. All right, and then from there, we're going to have y equal to negative 1/2 the natural log of u minus u squared over 2 plus c. We need to solve for c, so we're going to first plug back in our values. We got y equals 1/2. And then that's going to be times another 1/2 because we're going to take this 1 minus x squared minus the natural log of 1 minus x plus c. Okay, so again, we know that y equals 0, so we're going to have 0. And we know that x is going to be equal to 0 also, because y and x are going to be the same, because alpha and beta are the same. 0 equals 1/2 times 1/2 times 1 squared minus the natural log of 1 plus c. Taking it, let's just erase, ran out of room. So we're gonna do C on this side, and we're gonna multiply, we're gonna subtract C, but then we're gonna multiply by a negative on this side. So we're gonna have negative 1/2 times 1/2 minus 0 is plus C. And then we're gonna have, oops, not that, just kidding. Let's see, yeah, okay. Oh, and then that's gonna be equal to negative 1/4. Perfect. So plug C into the equation. We have y equals 1/2 times 1/2 times 1 minus x squared minus 1. Okay. Minus the natural log of 1 minus x. Perfect. Okay. Sweet. And then as we can see from here, that when x is going to be equal to 0, y also has to be 0. So when, when x equals 1, alpha equals beta. So y is going to be shooting to infinity. So this is just never going to, alpha and beta, it's never going to happen. She said, don't call.